The broadcast is now starting. All attendees are in listen-only mode.
Good day, everyone, and welcome to the August Pacific Northwest DEWS Drought and Climate Outlook webinar. My name is Holly Prendeville, and I'm the coordinator for the USDA Northwest Climate Hub. This bi-monthly webinar series hosted by NIDIS, the USDA Northwest Climate Hub, and Oregon Climate Change Research Institute. It is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar will be tailored to reflect recent, current, and forecasted conditions and climatic events, but will also include discussions and observed impacts and other relevant updates from across the region. Webinars and recordings will be available and posted on drought.gov later this week. For today's webinar, we will have a climate recap and current conditions from Larry O'Neill, the Oregon Climate Office, from the Oregon Climate Office and Oregon State University. We will also hear from Troy Lindquist with the National Weather Service Weather Forecast Office in Boise, who will provide the seasonal conditions and climate outlook. And special thanks for Troy for stepping in to cover for Brent Brower, who is currently deployed on wildfire assignment. So thanks to both. And then for our last talk, we'll hear from Karen Bumbacco from the University of Washington's and also the Office of Washington State Climatologist. And she will discuss the annual Pacific Northwest Water Year Assessment, lessons learned and how you can contribute. And also just a reminder, at the end of today's webinar, you'll have an opportunity to provide us feedback about this webinar series. Let us know what you think. Before we begin our webinar or presentations, we wanted to highlight the partners who make this webinar possible. The Northwest Climate Hub develops and delivers science-based region-specific technologies and practical information to assist managers with making climate-informed decisions in Idaho, Oregon, Washington, and Alaska. The Oregon Climate Change Research Institute is a network of dozens of researchers at Oregon's public universities that work closely with other public and private entities. OCRI is housed at Oregon State University and advances understanding of the regional climate impacts, adaptation, and cultivates climate-informed communities. NIDIS was established in 2006 by public law with the mission to improve the nation's capacity to proactively manage drought-related risks by providing those affected with best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS is building the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that the impacts and early warning information differ across the regions. Each DEWS has many of the same base ingredients, but ultimately their own flavor to reflect the needs of their region. The Pacific Northwest DEWS was officially launched in February 2016, and their strategic plan and information can be found on drought.gov. To facilitate this early warning system, more precipitation observations are needed. We encourage you to join COCORAS, the Community Collaborative Rain, Hail, Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds, working together to measure and map precipitation, including rain, hail, and snow, as well as condition reporting. Observations by COCORAS observers of precipitation events and the lack of precipitation are important events to capture and improve our understanding of weather. To become a volunteer or learn more, please visit cocoras.org or contact your state coordinator. Their contact information will be included in the chat box. So some highlights, some news from our Pacific Northwest DEWS. We have a save the date for the Oregon-Washington Annual Water Year meeting. This is the 17th meeting, and it will recap the 2022 water year and give an outlook for the 2023 outlook water year. These will be 2 virtual meetings held on the 25th and 26th of October. The goal of the meeting is to share and gather information regarding climate impacts and continuing drought in some areas, flooding that occurred in the fall of 2021, and the exceptionally wet spring will be the focus of this meeting. This meeting will also offer an opportunity to learn from others about mitigation actions that were taken. Both days will include time for discussion and peer-to-peer learning, in addition to hearing from forecast experts on what to expect for 2023. Karen, our last speaker, will be talking more about this and the annual water year assessment during the third presentation today. There we go, right direction. Since 2011, NIDIS has partnered with NOAA's Modeling, Analysis, Predictions, and Projections Program, or MAP, to support drought-focused competitive funding opportunities. The fiscal year 2023 MAP competition will focus on the critical state of Western hydroclimate and advancing our understanding and capabilities to address the challenges posed by variability and change in that hydroclimate. MAP is seeking proposals for research that can advance model-based understanding, monitoring, prediction, predictability, and modeling representation of drought. There is a need for research that can help discriminate between long-term aridity and serial drought events versus isolated drought events, and improving understanding of how the propensity for and drivers of drought in the West are changing. The webinars will focus on identification and implementation of climate change adaptation options, applying for specific funding for its resilience and adaptation projects, and training overviews and details of the 5 Climate Resilient Evaluation and Awareness Tool, or CREAT, modules. And then I want to share with you that NIDIS is co-leading the Drought and Human Health Workshop with the University of Nebraska Medical Center, along with a number of Pacific Northwest partner organizations. Space is limited, so if you're interested in attending this event, please reach out to Britt Parker, whose email will be added to the chat box, or visit the registration page for attending. And with that, we will go over to our speakers, with our first speaker being Larry.
All right, good day, everybody. My name is Larry O'Neill, and I'm with Oregon State University and with the Oregon Climate Services. And I'm really happy to be here today and to talk about the climate recap and current conditions for summer of 2022. So I wanted just to kick things off by showing a picture of one of my favorite clouds. They're altocumulus castellanus, and they often form in association with monsoon variability in July and August. And so these are often in the right conditions give rise to thunderstorms and showers that are very beneficial to our landscape. And we've had a few of those this year. So some of the hot topics I'm going to touch on briefly during this webinar is we're going to talk about the drought update and what improvements that we've had over the last several months. I'm also going to talk about the North American monsoon and how active has it been this summer in the Pacific Northwest compared to what we typically get. One thing, so we know it's been hotter than normal for the last month, but it also has felt more humid than normal. So does the data bear that out? And finally, I want to close with just some perspectives on the cool, wet spring that we had in 2022, and because it really did a very good job at shaping our summer conditions in the Pacific Northwest. So this is our current U.S. Drought Monitor depiction over the U.S. West. And so just to orient you here, the colors represent different drought intensities from moderate drought in D1 in the light tannish color to orange, red, and brown, going to severe, extreme, and exceptional drought. So you see a lot of the U.S. West is drought prone again this year. And within the Pacific Northwest, probably the worst affected areas are in central and eastern Oregon and parts of southern Idaho and western Montana as well. So how does this compare to this time last year? Well, you could see that at this time last year, the majority of the Pacific Northwest was either an extreme or exceptional drought, which are the 2 worst drought categories. By many measures, it was one of the worst droughts in the recorded history in the Pacific Northwest, and really throughout the U.S. West in general. And it was just really surprising to actually look back at this map, because I had forgotten how bad the drought was last summer. And if we go back to the in June of this year, the drought conditions were about the same as they are now. We've had a few small improvements over the last 2 months throughout the Pacific Northwest, but nothing too different. So we're kind of in a holding pattern, particularly in Oregon and southern Idaho, in our 2 worst places. So just to look at the aerial coverage throughout the Pacific Northwest region. So currently, this column here shows that there's 38.5% of the area is completely drought-free or not abnormally dry. So that is great news. Compare this to this time last year when 0%, as there's nothing in the Pacific Northwest that was not abnormally dry. And the comparing it to earlier this summer, it hasn't changed much. Slight improvement. And the 2 worst drought categories, or the 3 worst, severe, extreme, and exceptional drought, have not changed months over the summer. So about 11% is in severe drought, 11% is in extreme drought, and about 0.5% of the area is an exceptional drought. And this is just a marked improvement from last August, where about 86% of the Pacific Northwest was either in severe, extreme, or exceptional drought. So takeaway here is that the drought severity and extent have improved somewhat since the spring, and it's significantly improved since this time last year. Now, if you go back and just look at a time series of the different drought categories, so the U.S. Drought Monitor started approximately in 2000, and so this shows the time series of the drought categories, the percentage of area in a particular drought category since 2000. So we're over here in the middle of 2022. And our current drought episode, just a reminder, started in the fall of 2019. And it's definitely the most intense that we've had during for this duration of the U.S. Drought Monitor since 2000, in terms of its length and also in terms of its intensity. Now, right now, we've had, because a good part of our region is still in either severe drought or worse, there have been a number of county level drought declarations that are currently in force right now. So in Oregon, 17 counties currently have a state drought declaration status, and I've showed these counties here and with the names of these counties. All these counties also had a drought declaration last year as well, in addition to a few others. And then in April, Idaho declared all these counties south of the Salmon River, and with a drought declaration as well. And really good news is that the drought declaration that was in force in Washington State has expired. So there's no drought declarations in Washington State currently, and also in Western Montana as well. So last in June, when we had a few questions about the Washington State drought declaration process, and the question came about because the U.S. Drought Monitor had some drought depiction in central and eastern Washington, even though there wasn't a drought declaration. So in Washington State, drought is defined as a geographical area having less than 75% of normal water supply and anticipated hardships due to water shortages. So if both these criteria are not met, then drought does not exist, at least by the Washington statutes here. So the U.S. Drought Monitor takes into account other physical factors, including soil moisture, snowpack, and other things when determining drought status. So a region might be in moderate drought without an official drought declaration. And thank you to Jeff Marty for giving us this explanation here. So I just want to go through just the basic meteorological conditions for this summer. So we started off in June. This is just the mean temperature percentiles. So these percentiles show, the blue colors show places where the air temperature was cooler than normal, and then the red colors show where air temperature was warmer than normal. And so at least for June, most of the Pacific Northwest was near normal, even though there are a few patches slightly above or slightly below normal. But quite frankly, we had a quite delightful June throughout the Pacific Northwest, at least in terms of temperatures. Then July rolled around, and even though the 4th of July was a little cooler than normal, we started heating up, and of course we had that prolonged heat wave during the second half of July and through parts of the first parts of August. And this map just shows that the average temperature for the month of July from most of the Pacific Northwest was much above normal throughout, with even a few scattered patches of record warmest throughout. Precipitation, on the other hand, even though we've had a lot of thunderstorms, or it seems like we've had a lot of thunderstorms throughout the Pacific Northwest, the last 60 days have actually been very warm, or very drier, much drier than normal throughout the Pacific Northwest. You know, we typically don't get that much rain at this time, but in central and eastern Washington and Oregon and parts of Idaho, you know, about 10 or 20% of their annual precipitation comes during July and August, when we have these monsoon pulses that come through, so these showers and thunderstorms that bring us moisture. And we just have not had very much rain, except for the most southern part of Idaho down here, and then scattered parts in a little bit in central Washington and southern Oregon. But for the most part, it's been much drier than normal throughout. So where does this leave us with our water year 2022 precipitation? This map just shows us the percent of normal for the precipitation from October 2021 to July 2022. So this is our water year 2022. And basically, the water year is shaping up pretty good if you're north of about this red line here, which is at about 44.5 degrees north latitude. So if you go north of this line, most places are either, you know, near normal or well above normal throughout. So that is really great news. South of this line, the news isn't quite so good. In southern Oregon and Idaho, we've had mostly either below average precipitation or well below average precipitation. And what's really concerning about this trend is that this has been, especially in southern Oregon and parts of southern Idaho, these have been the worst hit areas in the last couple of years in terms of our current drought cycle here. So this precipitation pattern is roughly in line of what we expect during a moderate La Niña. And that's all I'll say about that. And I wanted to also give a little bit more perspective on the spring precipitation that we received, now that we've gotten more than preliminary data in. So if we flash back all the way to April, May, and June of 2021, the Pacific Northwest experienced one of their driest springs on record. And that's what this left-hand map shows, is just the percentiles of the precipitation during these 3 months. And there are quite a few regions that experienced their record driest, but nearly all other regions were well below normal in their bottom 10% of the driest years, with records going back to 1895. Fast forward to our April, May, and June of 2022, and most of the Pacific Northwest was well above normal precipitation. And these dark green patches, those are very good patches to see. That means that they experienced the record wettest in their since 1895 throughout, and most other regions experienced their much above normal, so their top 10%. So the spring precipitation in 2022 was beneficial and really materially improved drought conditions in the northern parts of the Pacific Northwest. And I'll just want to say that the whiplash between these two different springs was really a challenge in advising people on water supply and wildfire risk issues, because we just were not sure what to experience and this will be a challenge going forward. Is, you know, if the winter time precipitation isn't well above normal, and then we're really going to depend on spring conditions to make up any deficits. And you know, these last two springs really showed us that we can go back and forth into extremes in either direction. So this is just some summary statistics on our the two April, May, June spring precipitations for 2021 and 2022. So Oregon, Washington, and Idaho experienced their third driest 2021 spring on record, and Montana had their seventh driest. And 2022 spring, Oregon had its second wettest, Washington had its third wettest, Idaho has 17th, and Montana was kind of somewhere in the middle for its 52nd wettest spring on record. So this just shows you just the kind of that whiplash between the two spring periods. And I want to give one more perspective on just the current drought cycle. So the current drought cycle started in October 2019 and continues to this day in much of our region, including Central Oregon and Washington and Southern Idaho here. And what this map shows is just the precipitation deficit as a percentage of the annual precipitation here. So a value of minus 100% would mean that since 2019, that region has missed out on an entire year's worth of precipitation. And unfortunately, we see quite a few of these brown, dark brown patches here, particularly in Northern California, going through Central Oregon and into Central Washington here, and then also some spots in Central and Southern Idaho and Northern Nevada and Utah here. So basically, I think it's just a kind of a really sobering statistic that that really kind of points to why these regions are still in such incredible drought conditions, particularly in Central and Eastern Oregon. Many reservoirs are going dry again this year for only the first or second time in history. And so we're still feeling these water supply issues very acutely here. Now, if you're like me, it has felt more humid than normal the last several weeks. And is that true? So the surface humidity is often represented as the dew point temperature. And so I just plotted a map here of the dew point temperature anomalies throughout our region for the month of July. And so the warm colors mean that the dew point has been higher than normal, and so it's been more humid than normal. And then the cooler colors show that the dew point has been lower than normal, or that the air has been drier than normal. And so we see much of Western Oregon, Washington, and parts of Northern Idaho and Western Montana have indeed had dew point temperatures that are much warmer than normal, so between about 2 to 4 degrees Fahrenheit warmer than normal. And this was actually, if you look just at the end of July during the heat wave, we did set some records for dew point temperatures during that time period. And while I won't show it here, much of Western Washington and Oregon had their third highest average dew points since 1979 here. So it has been just definitely anomalously sticky out. Now, this hot, humid weather has contributed to reducing evaporative demand in parts of the Pacific Northwest. So actually, I want to go back to the slide. I want to make one more point here. Parts of Northern California, Nevada, Central Oregon, and Eastern Washington had dew points that were well below normal. So this means the air was drier than normal, and the relative humidity was lower than normal. So this has actually contributed to enhanced evaporative demand in a lot of southeastern Oregon and parts of Idaho and western Montana. But even though we were so hot during July, we did not get a big bump in evaporative demand in western Oregon and a lot of western Washington and eastern Washington as well. And this is partly due to the fact that it was so humid out. So it was so humid, there was, it didn't contribute to very much evaporative demand, which is actually good news for our drought conditions and also for our fuel moisture conditions in those parts of the state. Now, why has it been so sticky out? Well, there's one contributing factor, basically, is that the entire North Pacific Ocean is historically warm for this time of year. So if you all remember the blob that we talked a lot about a few years ago, it's become a seasonally recurring feature in the North Pacific. And right now it is in full force out here. So this left map here shows the sea surface temperature for the North Pacific, the anomalies. So this just shows that the the surface of the ocean is 68 degrees Fahrenheit warmer than normal, and it's really the whole North Pacific is much warmer than normal. And then on the right map here shows the dew point temperature anomaly for the entire Pacific. So you can see that the dew point is well above normal for the entire, almost the entire northern hemisphere, really. And you can see where we're at here. So the sea surface temperature, having warm water, it increases evaporation and increases the moisture in the near surface air. So, and this air has been finding its way into Western Washington and Oregon. So that is one contributing factor here. Now I want to finish up by talking about the North American monsoon. So it's been known to impact the US Southwest, but it can also influence the Pacific Northwest. It brings precipitation via thunderstorms and showers. We get widespread lightning and occasional hail throughout the region. So this is just a visible imagery of one day here, and I'm going to show an animation real quick. So this is just over a 4-day period in August, and what you're seeing here is clouds, obviously, but then all the flashes you see are lightning density. So the brighter the more oranger the color, the more lightning flashes you get. And so you see that during this, so this is a 4-day loop, and so you see a lot of these showers and thunderstorms impacting the Pacific Northwest all through here, with some really impressive displays. We've had some big hail in pretty much every state in the Pacific Northwest over the last several weeks. So you see these just nice, so the monsoon, basically you get the southerly surge here, and then it tilts back to the northwest here. And during this time, you see this feature spinning out here in the Pacific Ocean. This is a low pressure that was hanging out over California, which helped to enhance some of the monsoon moisture here. And so the monsoon, basically, this just shows the precipitation anomaly for the last month over the US. So we got a huge, the monsoon has been very active over the southwest US, particularly Nevada and parts of Arizona, Utah, but it's really missed us up here in the Pacific Northwest. And this is because this high pressure ridge, this is an anomalous high pressure ridge, so the jet stream has just been further north. And so it's given us this northwesterly flow component that's pushed back against the monsoon moisture. So even though that we did get some, and it seems like we've gotten a lot of thunderstorms, we haven't really gotten the rain that we usually get with it. Now, this is also corroborated by lightning strike. Yes?
Are you able to wrap up in the next minute, please?
Yes,
Thank you.
I will. Yeah, so the lightning strike data shows that we're actually well below average in the number of lightning strikes, according to the Northwest Interagency Coordination Center. So during June, we got 86% of average in lightning strikes. July was 59%, and August was about 93%. So we're well below. So while there have been active periods of monsoon periods in the Pacific Northwest, it is still a lag behind historical conditions. So just a summary and the key points. The summer has been exceptionally warm and dry after a cool, wet start. And much of the Pacific Northwest is still in drought, although the drought severity and extent have improved by the spring precipitation that we had. The summer monsoon has been active, but is still brought below average precipitation and lightning to the Pacific Northwest. And much of the Pacific Northwest has experienced more humid conditions than normal. That's really helped keep our soils and fuels a little bit moister than they have been in recent years. So anyway, thank you very much.
Thank you very much, Larry. Next, we'll hear from Troy Lindquist for that outlook. And if you have any questions for any of our speakers, please put them in the question pod and we will get to them at the end of all 3 presentations. Thank you.
Okay. Hi, everybody. I'm Troy Lindquist. I'm the service hydrologist from the National Weather Service Forecast Office in Boise, Idaho. And I wanted to start off, I like to start off with pictures, and this is what I like to use as a local drought indicator. This was from the middle of May this year. And as Larry already summarized, we had very wet conditions this spring. And but despite those very wet conditions, this reservoir had little or no precipitation or water in it, and the Indian Creek that feeds into it was dry all spring long. So indication of longer term dryness and drought across the region. So I'm going to talk about today, I'll provide a summary of Enso, or El Nino Southern Oscillation. Then I'm going to move into kind of temperature and precipitation outlook for late August into the very early part of September, and some potential for well above normal temperatures over the Pacific Northwest. And then I'll finish up with the seasonal outlook. Okay, so for the Enso summary, there is a La Nina advisory in place from the Climate Prediction Center. So we have La Nina conditions present across the tropical Pacific Ocean area. Equatorial sea surface temperatures, or SSTs, are below average across most of the Pacific Ocean. And the tropical Pacific atmosphere is consistent with La Nina. That means the cloud patterns, rainfall patterns, and the wind patterns and everything, outgoing, incoming solar radiation is all consistent with what we would typically see during a La Nina pattern. And La Nina is expected to continue into the winter, although chances of that continuation do trend down. They are still favored to continue into the December and February period of 2022 and 23. The image on the right shows the sea surface temperature anomalies, so departures from normal. The blue colors, or the cool colors, show those below normal temperatures across the region, and the reds are the above normal. I've highlighted the Nino 3.4 region because that's what the Climate Prediction Center uses to really focus on the Enso state and kind of put the either La Nina, El Nino, or neutral situation into context and characterize it compared to historical cases. So looking at the probabilistic Enso forecast, the graph on the right, the blue bars show La Nina, then the gray is for neutral Enso, and then the red is for El Nino. And on the left, or the y-axis, we have the percent chance probability of each of those categories occurring. And on the x-axis along the bottom, these are the seasons. They are 3-month, overlapping 3-month periods of time. So the far left one, that JAS, is July, August, September. Then move right, that's August, September, October, and so on. And you can see where we currently are, kind of that middle of that July, August, September period. Very high probability. We have La Nina conditions, but as we move through time, we go to the right, you can see those blue bars gradually start to drop off as we move to late fall into the winter time. And by the core winter months, the December, January, February period, you can see that 60% probability of La Nina conditions continuing. So again, it's favored to continue through the winter. And then as we move into the springtime, we can see that Enso neutral conditions are favored as those gray bars trend up above that 50% line. If we look at the Nino 3.4 region sea surface temperature model outlooks, the majority of the models indicate that La Nina is expected to persist through the winter. And if we look at our graph on the right, you can see the colored areas. The light blue is La Nina, and the gray is neutral, and then the red is El Nino. But we're currently, the x-axis has our seasons again along the bottom. You can see where we currently are at. The thick black line is for June, summer months. And as we move right, you can see both the dynamical models and the statistical models all kind of hang down in that blue La Nina area. And so pretty large majority of them are forecasting it to continue through the winter months. And if that does indeed happen, this will be only the 3rd time that we've had 3 La Nina winters in a row in the 73-year record. So that's quite anomalous to see 3 in a row. And as a reminder, we've probably, most of us have probably seen this graph before, but since the current water year is coming to a close, everybody's wondering what we can expect for next winter, I'm sure. And this is a typical La Nina wintertime pattern over North America. Again, I say typical, there are some variations and we'll touch on that in a bit, but what we typically see is wetter than normal conditions from Northern California across Oregon and Washington, and broad swath of cooler than normal temperatures from British Columbia down across the Pacific Northwest, Northern Rockies into the Northern Plains. And as I mentioned, that's typical, but not always. And a lot of graphs here, but I think to simplify it, just the ones on the left here with the reds and the blues, that's showing winter temperature departures from average during La Nina winters. So we're looking at all strong, moderate, and weak La Ninas. I think there's 21 cases here going back to 1950. And if you remember, it shows La Ninas typically have those cooler than normal temperatures over the Northwest and Northern Plains. You can see those blue colors indicating those cooler than normal temperatures for many of these cases, the majority of them. You can see even the strong, moderate, and weak La Ninas. So there are a few cases, though, especially across the top. You see the two on the right of that top row. There are some red areas where we've had above normal temperatures. Then you drop down to the second and the fourth row, and you do see La Nina years where we had just normal or above normal temperatures. So again, it's not always the case that we're guaranteed that we're going to have below normal temperatures. And if we shift over to the graphs on the right, similar type of deal for precipitation. The greens show areas where precipitation was above average, and the browns show where it was below average. And again, typically, most of the time, we'll see above average precipitation across the Northwest during La Ninas, but you do see on some of these La Nina winters that we had the browns showing below normal precipitation. So I'm going to move on to our temperature and precipitation outlooks, but before we get into some of the CPC charts, I just wanted to touch on our 7-day precipitation forecast from the Weather Prediction Center. So that's a total precipitation for the next 7 days, takes us into next weekend. Not a lot of green shown over the Pacific Northwest, unless you kind of get east of the divide over into Montana. So a lot of that light green you see over Washington and Northeast Oregon and Idaho is going to be hit and miss showers and thunderstorms, less than 1/10 of an inch. As the fire weather community puts it, that we're not expecting wetting rains. So very light precipitation and very spotty at best. So the Climate Prediction Center 6 to 10 day precipitation and temperature outlooks indicate below normal precipitation favored. You can see that on the left side across almost all of the Pacific Northwest. Meanwhile, our temperature outlook strongly favors above normal temperatures across the region. And we move on to the 8 to 14 day outlook, similar type of situation. Lean towards drier than normal or below normal precipitation for most of the region. Meanwhile, we maintain that bullseye of strongly favoring above normal temperatures across the Pacific Northwest. Now, are some concerns for getting some excessive heat or well above normal temperatures over the Northwest, and this might look a little bit complicated, but what my main point what I want to show here is the uncertainty and the variability among the models as far as how warm or how much above normal temperatures might be as we get into the early part of next week across the Pacific Northwest. And what I'm showing here is the 8 to 10 day model ensemble clusters. So we have 3 models here, and there's variations within each of those models. And as we analyze those models, they are grouped into similarities or clusters that are showing a similar pattern. So we have cluster 1, 2, and 3 from left to right across the top, then cluster 4 in the lower left. than the total mean on the lower right. So just want to point out in cluster 1 here, you can see very strong height anomalies, positive height anomalies, or greater than normal, over kind of centered over British Columbia and the Pacific Northwest. Cluster number 2, well, that cluster 1 is 21% of the models. Cluster number 2, you can see that ridge axis and those height anomalies shifted further east. That's 37% of the models. Then cluster number 3 on the far right actually shows some negative height anomalies just offshore, and that ridge is further east yet over the Central Plains into southern Canada. Then kind of cluster number 4, you can see some variation from the top 3 there as well. So again, there's a lot of variation, a lot of uncertainty in how warm those temperatures might be next week. And then finally, you can see the average on the lower right, where the ridge axis of all the ensemble members is kind of mainly just east of the Northern Rockies. So with all that said, the Climate Prediction Center, if you look at their risk of hazardous temperatures for August 29th through September 2nd, they've got slight risk for excessive heat in this kind of the smaller dotted line stretching all the way through California up through the Western Great Basin and Montana. Then they've got a moderate risk of excessive heat for the last 3 days of August over much of Washington, Oregon, and northern Idaho and northwest Montana. So let's look at our seasonal 3-month outlooks from the Climate Prediction Center. This is for September, October, November, and you can see over much of Washington, kind of the northwest half of the state, just a slight lean towards above normal precipitation, with equal chances for just about everywhere else across Oregon, southeast Washington, and most of Idaho. And you can see the temperature outlook for that 3-month period on the right leans towards above normal temperatures for most of the region, except maybe the southern third, a good chunk of Washington and the Idaho panhandle. So we'll jump ahead to the next 3-month period, October, November, and December. You can see that area of above normal precipitation being favored is expanded kind of eastward into the Idaho panhandle and northwest Montana. And I think we're starting to see the impacts of being in La Niña Enso phase. If you think back to that typical wintertime La Niña pattern graph that I showed you a few slides back. Then on the right, you can see our temperature probabilities favor above normal for kind of the southern southeast half of the area, and equal chances of either above, below, or normal temperatures for the northwest half of the region. And finally, we'll move ahead to our core winter months, December, January, and February. You can see, looks like we have that La Niña flavor over the area, with above normal precipitation favored for some of the northern areas. And we see those probabilities slightly favoring below normal temperatures for mostly some of the northern areas across the region. And again, there's that typical La Niña pattern, and definitely see that reflected in those CPC outlook charts. And I know they look at things like soil moisture trends, and certainly the Enso phase plays a big role in their seasonal outlooks. So the U.S. seasonal drought outlook released the end of last week. This goes through the end of November. Areas where we currently have drought that were pointed out a little bit ago are expected to persist. So much of Oregon and southern Idaho are expected to continue with their drought situation for the next 3 months. And if we look at the predictive services from the National Interagency Fire Center for significant wildland fire potential, current month, August, on the left, you can see those reds are above normal significant wildland fire potential. So a good chunk of the northwest, inland northwest, southern Oregon, and a good chunk of the northern Rockies. And if we move to the middle graph for September, you can see generally the same areas, a little bit more of Idaho. And then by the time we move into October on the right, looks like just normal for the entire Pacific Northwest region. Again, these are, significant wildland fire potentials, you know, looking at things like fuels, drought conditions, you know, but we do need the ignitions and the right weather patterns to make that, you know, those fires come to fruition. So it's not a guarantee we're going to see, you know, a lot of large, significant wildland fires. So just to summarize what I've talked about, La Nina is present and favored to persist through the winter 2022 and 23. Above normal temperatures favored through the fall for most of the Pacific Northwest, and below normal temperatures favored for the northern half of the region this winter. Above normal precipitation favored this fall and winter for much of Washington and the northern Rockies, and the drought is expected to persist for much of Oregon and southern Idaho through the fall. That's all I've got.
Thank you very much. If you have any questions for our speakers, again, you can put your questions in the question pod. Next, we'll hear from Karen Bumbaco.
Hi, thanks, Holly. All right, final leg of this relay. I think I should be able to go through with it, so we have a few more minutes for questions. So I'm just going to talk today about the annual Pacific Northwest Water Year Impacts Assessment. If you haven't seen it already, go ahead to the next slide, please. So we have had 2 water year reports put out already, one reviewing the 2020 water year and then another the 2021 water year. We expect to do the impacts assessment again for the water year that we're currently in. And although we always think maybe we could get out this report a little sooner in the season, it's pretty likely it will be released in February of 2023. It just takes time to get all this information pulled after the close of the water year. So this has been a collaborative effort. I have a long list of people that have contributed to this report, either content or reviewing. So Larry, who just spoke, the Oregon State climatologist, is involved in this. Oregon State's OCRI, the Washington State Department of Ecology, Idaho Department of Water Resources, the Idaho State climatologist, the Oregon Water Resources Department, the USDA Northwest Climate Hub, NRCS, and also the Nez Perce Tribe was involved in the 2021 report. So a long list of collaborators, and it's been supported by NIDIS. And really the purpose of this report is to summarize the water year conditions, take a look at the impacts from those conditions by sector, and hopefully have this be a resource for future management of drought and other climate extremes. So the 2021 report, for example, mainly focused just on drought, while the 2020 report, we had some flooding that year that was also highlighted in that report as along with drought. And so in these reports, we review the weather and climate conditions of the water year impacts. We talk about response actions taken in the Pacific Northwest. And we also have a section that reviews sort of a snapshot of what the seasonal forecasts, what 1 or 2 seasonal forecasts released from the Climate Prediction Center were, and then how well did that forecast actually turn out. Next slide, please. So there's kind of 3 different sources of information that go into these reports. The first are water year meetings that are held annually. There's typically one that is joint between Washington and Oregon, and then a separate Idaho water year meeting. And at those meetings, discussion of conditions and impacts takes place in some way, shape, or form. It's varied throughout the years on how we get that discussion at those meetings. And then many of you have probably also heard about the National Drought Mitigation Center and NIDIS's Seymour Drought Survey. So on the lower right-hand side there, that's a snapshot of the condition monitoring reports for 2022 so far. And that's a survey that is available at any time, where you can enter your point observation and assess on whether you're on the drier side or the wetter side and what impacts you're seeing. You can upload photos. So we pull in those impact reports for the water year to take a look at. And then we have another survey that we have named the Annual Pacific Northwest Water Year Impact Survey. It could perhaps have a better name. It's not as fun as the Seymour Drought one. But this one looks back at the water year as a whole, so it's only available like right at the end of the water year. Historically, it's been geared a little bit more towards state agencies or utilities, irrigation districts that can kind of answer overall for what they have seen over the water year, a bit in the rearview mirror, and sort of entering an overview of conditions for that water year. So both of the surveys, the Seymour Drought and the End of the Water Year survey, you can enter impacts by sector. So that's the list there for the sectors that are included in the Pacific Northwest impact survey. Next slide, please. So Holly stole my thunder a little bit at the beginning here. Registration is now open for the Oregon and Washington Water Year meeting. You have not received any emails or announcements about it yet. It's just open as of today, and by today or tomorrow we'll start sending out emails announcing that this meeting is happening. It's virtual this year. We're going to split it between 2 morning sessions like we did last year to kind of break up the day a little bit, and you can register. It's free to register, but we do need to, of course, send you the link and know how to contact you, so that should be entered in the chat too. Next slide, please. So I also wanted to, kind of going back to the Water Year Impacts Assessment report, for the 2021 report, we highlighted a section that we called Lessons Learned to talk about what really jumped out at us from the water year. And this Larry pretty much covered, but I wanted to just take a few minutes here to go over some of those lessons learned for the 2021 report, just to give you an idea of what is in these reports. So this lesson 1.1, spring was unexpected and perhaps underappreciated with how quickly conditions could turn, I think would be the take-home point. Larry described this well. On the left-hand side there, that's April 1 snowpack % of normal, especially for Washington, northern Idaho, and northern Oregon. Our snowpack was well above normal by April 1. And then on the right-hand side, that's the March through May precipitation % of normal. So we heard about how dry it was last year, just illustrating really how those conditions can change rapidly and maybe a little bit underappreciated with how much spring can impact our conditions here in the Pacific Northwest. Next slide, please. So another lesson talking about the widespread impacts on multiple sectors that resulted from the June 2021 heat wave demonstrates the importance of planning and preparing for short duration extreme temperatures in addition to monthly and seasonal temperatures that are typically monitored for drought. So this was just talking about how, of course, we know that heat waves can impact conditions, but maybe a lesson here in that, we're so used to looking at monthly and seasonal forecasts on our drought monitoring committees, for each individual state in the Northwest, that, heat waves and even cold snaps can be more important and impactful than we maybe give credit to. So that this is an image here pulled right out of the 2021 report showing that June through August statistics, record warmest for Oregon and Idaho averaged across the state, second warmest for Washington state. Next slide, please. And this one, Larry showed a very similar image, although mine stopped short. So this one here is the Standardized Precipitation Evapotranspiration Index, SPEI, for the 2 water years, October 2019 to September 2021. So this is taken right out of the 2021 report. So it doesn't have the last year, more or less, of conditions. But that lesson being, of course, multiple year impacts of drought are possible and warrant planning. Particularly for Washington, really rarely experiences multi-year drought because the precipitation in fall and winter is typically sufficient for recovery. And so seeing last year that we had, multiple years of precipitation deficits there in Eastern Washington and elsewhere in the Pacific Northwest, it just was a reminder of multi-year impacts that we are, of course, seeing now, even with our wet spring. Next slide, please. And then the final lesson I just wanted to highlight here are just more about how we record impacts. So the lesson being compounded impacts of climate change and variability are becoming more diverse and affecting natural resources, agriculture, and water supply. So for example, during the 2020 water year, we had impacts where from drought and the wildfires that we saw in the September of that year. During the 2021 water year, we saw impacts that were associated with the June heat wave and the extreme drought, so those combined. And it's really very difficult to tease apart the impacts that we're seeing. Well, is this due to drought or is this heat, and how are they related? So this is a snapshot from the 2020 water year impacts assessment. This is how we present sort of the responses from the survey. And we ask people, has it been dry or wet? And even that is difficult to sometimes put impacts into those two categories, because, you know, what if it's not just the dry conditions, but it's also the heat? And so just the difficulty in documenting sector-specific impacts is, you know, certainly complex, and perhaps there needs to be a different survey or a different way we go about that. Next slide, please. I believe this is summing it up here. So just to circle back again to that end of the water year survey, it should be available in late September or early October. It's a Google survey, and we will have it on our meeting website for the Oregon and Washington water year meeting. I should also say that we do want Idaho impacts entered into that survey as well, because the assessment covers all 3 states. And we had 52 responses in 2021, 40 in 2020, so there's certainly room for continued growth. Please consider sharing your observations once that survey is available and sharing it with others. I'd also be interested in any suggestions you have to certain listservs to send it to, or other groups to get that survey out to, because it really helps, you know, increase our understanding of impacts that hopefully can inform drought policy in the future. The survey also gives us an opportunity to learn response actions from others. So how are other people dealing with abnormally wet or abnormally dry conditions for the water year? Ultimately, as we keep doing this, we hope to document impacts to see change over time, and then ultimately better connect impacts to actual water year conditions are the goals of that survey. Next slide, please. So yeah, just to summarize, you can register for the virtual Oregon and Washington water year meeting now. Last I heard, the Idaho meeting is still being planned, so no date yet there for their water year meeting. Look for our end of the water year survey, and if you have observations right now, you can always enter the Seymour drought impacts at any time during the year. So thanks.
Thank you, Karen. I'll be turning it over to Britt Parker, who will be asking our speakers questions.
Great, thank you, Holly. So we've had a few questions. I've answered some of them in the chat box. We had one observation of 6 straight weeks of rain in South Central Alaska since mid-July. So thank you for sharing that. I do have a couple questions. The first one kind of came in as Troy was beginning. So I'll turn this over to either Troy or Larry, and that's, were the spring of 2022 and the spring of 2021 considered La Niña years? How were they so opposite in terms of precipitation, especially for Southern Oregon?
Well, I can speak to the La Nina part, and as I pointed out, this winter will be the 3rd La Nina in a row. So yes, the past 2 winters were La Nina winters, but often, you know, the impacts from La Nina, you know, maybe mainly felt over the winter time, or maybe a little bit into the winter and the springtime. But I think the main thing, again, the takeaway I tried to get across was not all La Ninas produce what we typically see, you know, above normal precipitation, cooler than normal temperatures, and that is exactly what we saw with the spring of 2021 and 2022. We just saw, as it was described, kind of a whiplash in our precipitation patterns across the area.
Great. And then a second question for you, Troy. Could you briefly speak to the number of 100 and 100+ degree days this summer in the Treasure Valley, Boise area?
Yes, I believe it was yesterday we set a new record for I think it was 21 days of having high temperatures of 100 degrees or greater. So again, that was a new record. I can't remember what year the previous record was. So yeah, it's been a very, very hot summer in the Treasure Valley.
Great, thank you. And one final question, which is a little broader. I'm not sure any of our speakers are ready to speak to this, but I'll propose it because I think it's an interesting one. And that is, given the extremely large variability between 2021 and the current year, or even going back further in some of the variability we see, what are some of the challenges of proposing or looking into drought mitigation and adaptation? I don't know if anyone wants to say a short note on that to close us out, but I'll throw that out there. I think that is one of the challenges of adaptation and mitigation, is planning across the spectrum when it comes to climate variability and extremes. So I think that's something to consider, and we hope to have more speakers. We've had a few in the past and more in the future who will be talking about what they're doing to adapt to the varying conditions that we see year to year. And to climate change. So thank you to all of our speakers today, and we look forward to seeing you next time. October 24th is our next webinar. Thank you so much for your time and energy, and we'll see you then.